Welcome back. I hope you all had a wonderful holiday season and I wish you a very happy new year. In our last video, we explored several examples of mutating admission policies in the Kubernetes. Today, we are diving into a feature that's both highly advanced and essential for Kubernetes admin, validating admission policies. Let's start with a bit of a history. In a Kubernetes version 126, the validating admission policies were first introduced as an alpha release and they were disabled by default. If you're using Kubernetes version 126 and 127, you will need to enable this feature manually by setting the feature gates and configure runtime config to v1 alpha 1 release. In a Kubernetes version 128 and 129, the feature was graduated to the beta 1 and was still disabled by default. To enable this feature, again, you will need to set feature gate and configure runtime config to the v1 beta 1 release. And finally, in Kubernetes version 130 and above, the validating admission policy has reached to the general availability. This means the feature is enabled by default and requires no additional configuration. In this video, I will walk you through how this feature works and how you can leverage it effectively in your cluster. Let's get started. In our previous video, we discussed about the benefits of mutating admission policies over mutating webhook configuration. The validating admission policies has a similar benefits over the validating webhook configuration: enhanced flexibility, declarative management, improved performance, and security and compliance. The validating admission policies eliminate the need to write and host external webhook servers. The policies are managed by Kubernetes API server itself, ensuring seamless integration and reducing the operational complexity. The validation rules are executed directly by the Kubernetes API server, avoiding network latency and external dependency, which means it reduces the risk of delays or failure caused by the external webhook unavailability. I'm on a release notes page of a Kubernetes version 126. As I mentioned, the validating admission policies were first introduced as an alpha version in this release. Now let's look at some of the examples listed on this page. Without wasting much time, let's apply this policy and see it in action. Let's call this is an v1 and then let's call this policy as a gamma policy. Okay, so let's go into the details of this policy. The resource rule specifies API groups, version, resource type, and operations these policy targets. Now the API groups. The apps API group means this policy targets the resources in the apps API group, which includes things like deployment, stateful set, and few more. API version. We have specified v1, means it applies to the version v1 of the resources in the apps API group. Operations. We have defined create and update operations. So this policy will validate when the new deployments are created or the existing one are updated. Resources. This ensures the policy only applies to the deployment objects. Validations. Validation has only one expression, and which is object.spec.replicas are less than or equal to 5. You can have a multiple expressions for the given policy. In this example, we only have one simple expression. The replica field in the deployment spec must be less than or equal to 5. Each expression must return true for the request to pass validation. If an expression returns false, the request is denied and the expression error is returned to the client. In our example, if someone tries to create or update deployment with more than 5 replicas, the API server will reject the request. Now let's apply this policy. Excellent. Now, in order to bring life to this policy, we will need a policy binding. Let's grab the code for the policy binding. Is the code. It's called binding. This is again in V1. Just to have a name consistent, and our policy is demo policy. Okay, so let's save this. In this policy binding, we have a match resources, and the namespace selector is used. The match expression has a key, environment, and the value should match to the test, which means any namespace has an environment, label, and a value is defined as a test will qualify this binding. And let's apply this policy now, the policy binding. Okay, looks like it's missing the validation actions. It must be due to the old document we are following. So validation actions are two types. One is deny and another is warn. I will go with deny. Okay, let's apply this again. Excellent. Now let's see this in action. ctl create ns test replicas. Okay, then let's label this namespace kubectl label ns test rep, and the label was, I think, environment equals to test. Okay, now let's test if the binding is in effect. Here run, this is not, this is deployment. So create deployment nginx image nginx, and let's say replica set equals to 6. Okay, replicas equal to 6, and replicas are created. So get ports. Now let's see, because this is we applied in the default namespace where our policy binding is specifically says you have to have a label which is environment equal to test. Okay, so now let's see if you say the test rep, and here we go. As expected, the deployment has failed and it has returned an expression object spec replicas equals to 5. Now let's make this message meaningful. So we add demo policy and let's add some message here. Message replicas in deployment should not be greater than 5. Okay, now let's apply this again. Okay, now let's see. Okay, so this is now more meaningful message than printing the expression itself. Now I will show you the message expression. This is next test. So I already have a message expression written for you. Okay, and when you have a message expression takes a precedence over the message. Okay, let's apply this and let's test this. So this is now coming from the message expression. Deployment spec replicas set to max replicas 6 and must not be greater than 5. Now let's add the failure policy. Okay, so you can say failure policy. Let's start with ignore. Okay, and I will show you how the ignore works. So suppose it is 5. Okay, so this is not a valid expression now because you cannot compare with the string. Now let's apply this. Okay, now let's see what happens. And it has been created, because what happens, we said ignore policy or failure policy is ignore. So keeps it here, get odds and test rep, and it has been up and running. So let's delete this again. Keeps it here, delete deployment Nginx and just typo, again typo. Okay, so now let's edit the policy again. I'll show you what the failure policy means. So when you say fail and now apply the policy again, and let's see now. Yep, so it has been resulted in error and it says no such overload, which is expected. Let's look at the behavior of a failure policy. When we define failure policy is to ignore, and we attempted to create a deployment with 6 replicas, the validation expression was evaluated to the false and the request was denied by the Kube API. If the expression had a syntax, the evaluation fails and the request proceeds, and this is what happened here. Okay, when the failure policy is said to fail, the validation expression still evaluates to false and the request is denied by the Kube API. But in case of the validation expression syntax, what happens is evaluation fails and the request is denied. When it is set to the ignore, the request still proceeds. That's the difference between two failure policies. Now let's add some audit annotation. Let's add audit annotation. If your Kubernetes cluster has auditing enabled, then audit annotation will write an event in the Kubernetes audit log, which is specified in the value expression. So let's apply this. Yeah, it is configured. I won't be able to show you the audit log because I haven't got an auditing enabled, but you can test this in your setup. Now let's take a look how we can introduce a variable in this policy. I'm going to edit the policy. Okay, let me add variables section, and we will call this as name and say max replicas, and okay, I forgot to add, then you need expression. This is not very complex expression, we just assigning a value, but it can be in a very complex expression as well. Okay, so we'll change this expression now to reflect the variable. So say variables variables dot our variable name, which is this looks good. This is never going to be executed, but I will just update this because, as I explained, this message expression takes a precedence over the message. Now let's edit this message expression where we have hard-coded value. Now we will add this string and variable max replicas. Okay, let's test this. kubectl apply -f demo policy.yaml. Or I'm not comfortable with this. No, that's all right. So kubectl create deployment nginx image equal to nginx and -n test rep. Okay, and the replicas, let's say 4, and you can see this is now has come from the dynamic variable which is specified within the policy itself. So this message is coming from the message expression, and you can see this in the policy. So this is where it came from. Now let's take a look how we can pass max replica as a parameter, which will be defined with the custom resource definition, which is CRD and external to this policy. So I'm going to visit my GitHub repository for this. Just bear with me. And yeah, so this is my public repository. Anyone has access. So go to the files. I have lots of validating admission policies written here. So I'm interested in CRD. I'm just going to grab this, and I'm going to apply into my setup. So I'm just saying param crd.yaml. Okay, so I'm only interested in this max replica at this moment, and I'm just going to apply this. It looks like I already have a CRD deployed to this cluster while I was recording the earlier video for mutating admission policies. So let's grab the param files. Okay, basically I'm just defining the values of a max replicas to, let's say, 4. Apply. Okay, now let's edit the policy. Okay, let's modify this code now and add param kind, and it is my K8s automate.com v1, and the kind is validation parameters. If I'm not wrong, I will cross check again. Right. Okay, so validation parameters was correct. Okay, so now we will change this from variables to params dot spec dot max replicas. Okay, which is coming from these validation parameters basically, and we will change this message as well to same. So let's insert this, and I think this is done. So let's save this and apply this policy. There is some error. Okay, I know what it is. So I missed the API version here. Yep, API version, and this kind should be in line with CTL. Apply. Perfect. Now we need to edit the binding as well and add param reference, param ref, I believe, and it needs name, and I need to check what's the name is, but let's see, parameter not found action, which is deny. Okay, I need to get the name at cat values. Copy. And the name of the parameter is validation parameters. Okay, so let's apply this. Perfect. Now let's test this in action. Create deployment. Again, nginx image equal to nginx replicas equals to 5. Okay, it already exists. Okay, we are supposed to test. Right. Okay, this is good. So this message has been came from the param kind. So we can say the must not be greater than 4, which is what we define. The max replicas is equal to 4. If we edit this file, suppose suppose vi, and then and says 2, this is very easy now to handle this kind of scenarios. And then ctl apply f1f, and now let's say then it will say must not be greater than 2. Excellent. Now let's move into the next example. Until now, I tried to show you some basic example of a validation admission policy and how it works. Now let's take a look at some of the complex policy. For that, let me show you one of the policy from my GitHub repository. So okay, I will take the first example, which is run as non-root. Okay, I will just copy this policy and let's go into the terminal. We are non-root policy.yaml. Okay, what this policy is, it has all the description. If you want to go, this is a public GitHub which I maintain. So this particular policy ensures that every container has a security context and run as non-root has been set to true. You can see that it has a various API groups. This is for the pods, which is in the default group. This is apps where you have deployments and replica set, daemon set, stateful set, the batch which has a job and cron job. And this is very complex in terms of because it is applying so much logic against all the policies. So this is mainly for the containers. Then this part is for init containers. This is for ephemeral containers if it is kind of a pod. And similar logic for deployment, replica set, daemon set, stateful set, and jobs. You have for a normal container, init container, ephemeral container, and for cron job. I will explain you why we need so many expression and why this is very important to have the multiple expression within the policy. But let's apply this policy and we'll see in action. And let's grab the policy binding as well. Okay, this is applied. Now let's see this in action. Okay, for that we need an pod. So ctl run nginx. I'll just copy this in the file so that we have .yaml and resources don't want it. Okay, now let's apply this. So this is definitely failing because the validation admission policy, which is enforcing and is saying that run as non-root set to be true. It has to be set to be true. So let's edit this and add security context and run as non-root to true, and let's apply this, and it has worked. So if you have noticed the message, it has all containers in the pod, so in a pod. So if I open the policy again, which was non-root policy, okay, and if I show you, so this is the message it has printed. Okay, now this is particularly checking pod as a resource. Okay, now let's see how it affects in the deployment. Okay, so let's create a deployment. Annex image in Annex, and then because we have other policy in, we don't need any replies, that's fine. And test rep dry run. Oh yeah, okay, so I'm going to grab this and so deployment.yaml. Okay, so let's get rid of this and let's see this, what happens when we apply this. Okay, so now the message is all containers in the deployment and replica set, daemon set, stateful set must set run as non-root. Why this message is? So this particular message is coming from a particular section of the policy, which is this section of the policy. I will explain you the detailed logic of this policy in a while. So let's focus on applying this. So let's edit the deployment and add security context. Where is the image? Okay, security context and run as non-root. Let's say false. What happens? Expected. Let's say true, and it should be okay. Now let's take a look at the logic defined in the policy and how the expressions are filtered and executed for a particular resource. Okay, let's open the policy, and as you can see, the resource groups are multiple resource group. The API group is default API group for the pods, and then you have apps for the deployments, replica set, daemon set, and you have API group for the batch as well. So I believe there is a limit of how many API groups you can have, how many resource rules you have in the policy itself. So I believe its a limit is 10. And yeah, so let's look at this policy expression. So as I explained, there are two key rules. If the set expression evaluates to true, the request is allowed by the Kube API. And if the said expression evaluates to the false, then the request is denied and the associated error message is returned to the client. Now let's look at the expression. So this expression is OR short circuit evaluation, which means for when it is a OR condition, if any condition is true, the entire expression is true and the subsequent conditions are not evaluated. If this was a AND, then if any condition is false, the entire expression is false and the subsequent conditions are not evaluated. Now let's see. So what happens here? Object kind not equal to pod. So this condition evaluates to true for all non-pod resources, which means for deployment, daemon set, stateful set, which means validation skips the further checks for these kind of resources. Let's go through one by one line. So the object kind not equal to pod, when you submit a pod resource, this statement becomes false. I'll just write it. We don't have any exclude namespace defined, so this will become false as well. And what it says does not have an spec containers, but we have the spec containers, so this will become a false. Now the next statement is very important, where object.spec containers, and we are looping through the all containers within the pod. Let's call this as a C, instance C. And what we are saying is the C has a security context. And now you see this is and operator. And means if any condition is false, the entire expression is a false and the subsequent conditions are not at all evaluated, which means if the container doesn't have a security context, this will be false and the other conditions will not be evaluated. Let's see if the security context is there. Then it will move on to the next code or next line, which says security context is present and run as non-user root is also present. If it doesn't present, then this will become false and then entire equation become a false. If the both conditions satisfies and returns true, it will move on to the next one, and it says security context run as root is, this is implicit, so this says it has been set to true, and if it is not set to true or if it's set to false, then this statement will return as a false and you will receive a message. Now let's look at the positive way of this short circuit. So I'm going to remove this false now, and let's say if our request is of kind deployment, then this statement becomes true. The moment this statement becomes true for the deployment, the rest of the equation will not be evaluated and it will move on to the next expression. I hope it all makes sense. Now let's look at the similar logic with the AND short circuit evaluation. I already have a policy. Okay, so it's the same logic, but with the AND short circuit evaluation. As I mentioned, for AND short circuit evaluation, if any condition is false, then the entire expression is false and subsequent conditions are not evaluated. If we pass an pod resource, then this condition will return as a true, and if it has a container, then this condition will return a true, and it has a similar logic what we seen in the OR condition as well. So let's apply for this policy. Okay, and let's see where pod deployment, so run as Okay, let's apply -f4.yaml, and you can see it is running now. False. Okay, so you can see that the validation policy has been enforced. And that brings us to the end of today's session. I hope you find it helpful. I would love to hear from all of you. Please feel free to share your comments and suggestions. They will help me to improve these videos and make them even better. As a special treat for all of my viewers, I am making my private GitHub repository public for next 7 days. This repository contains a variety of examples of validating admission policies that can help you to enhance your security of your Kubernetes environment. Don't miss it out and check it out. Thanks for watching. I will see you in the next video.